So good morning all of you. Now I want to discuss here principle of superposition. So just I want to clean this part, and now see what is principle of superposition. How can we tell these things here? Suppose we have many charges present here, one Q1, Q2, Q3. See, suppose this is Q1, right? Here suppose this Q2. Here suppose this Q3. Many charges. Here suppose this Q4. Assume this distance is R12, so this is R13, R12, this is R14, right? And this suppose R15, right? Simply I am asking, and suppose one another here Q1 charge, Q1, Q2, Q3, Q4, Q5, like that, Q1. This is R1N. I am asking one question, force net on charge N. How can we solve this question? Means we have many charges present and I want to calculate net force on charge N here. So here see one thing, here many charges present. So on this charge, force due to all remaining charges we have to write. Tell me due to first charge Q1. You can write here. Tell me this is repulsive or attractive? Repulsive. Okay, this is line joining. This force will be called F force on N due to first. Am I correct? Force on charge N due to first charge will be force on N due to 1. And here, tell me force on 4 due to first. And here tell me force on fifth due to first. Am I correct? Sure. And one thing here, tell me here force on N due to fourth, do this force on N due to fifth. Simply can write here force because I want to told suppose we have Fxy, force on X due to Y. Here I want to calculate force on this N. So here we have to write force on N due to first plus, yes, vector quantity, it is vector addition, force on N due to 2 plus force on N due to 3 plus force on N due to 4 plus force on N due to 5 plus force on N due to N minus 1. Understood? So this is called simply principle of superposition. Now I will give many problems based on this principle of superposition. Suppose we have one triangle A, B, C. Here plus Q charge, here also plus Q charge, here also plus Q charge. Force on C, net force on C means here net force you have to get net force. So okay, net force here, see here. If you want to calculate net force here, here. So due to A, this will be repulsive or attractive? Repulsive. So I think here this is called Fc due to A. Very good. And due to this, tell me, this is your line joining. I think repulsive. Here force on C due to B. Check. And assume here it has given AA, right? Side length it has given already given. So angle will be 60. This will be also 60. Am I correct? 60. And both are vector quantity. Now you understood. You know already how can we add the vector sum of that given vector forces. This is FCB and this is FCA, right? This angle is 60 degree. So FCB, tell me FCB. What is value? K, QA. QA is QB is Q, QC is Q. Okay, just I want to write KQ square by A square simply directly. Here FCA check, Here also K, Q square by A square. I think both have same magnitude. Just simply I want to write F. You can assume X as, because every step we have to write this KQ square by A square, every step. It will time take, right? So just I have assumed okay F, right? Now simply this is F and this F and this angle is 60. So what is the resultant? This will be under root F square plus 2 F1 F2 cos 60, correct? So R equals to 2F square plus 2F square cos 60 means 1 by 2 to consider. I think this will be F root 3 check. 3 square, so F root 3. Now I know what is F, I know, tell me. So we can write here Q square by A square root 3. That is your final answer. So this type of question you can solve by using that principle of superposition. Principle of superposition, nothing but just addition of all types of forces. Understood? All types of forces in case of electrostatic F12, F13, F14, F1n is vector addition. Next, we have this A point minus Q charges, B point plus Q charges, C point plus Q charges. Now, net force on A, net force on C, net force on A here. Here check, here due to this B and C, here force will exist. If this will not present here, so no forces will present, right? But due to B and C, I think here force will exist, correct? Okay. So due to B, tell me, this is line joining between charge A and charge B. Here attractive force or repulsive force? Repulsive force. So here tell me what is force value? FA due to B. Here tell me FB due to C, check. And here tell me due to this. I think here F, check, this is minus, right? Not, this is minus charge. So repulsive or repulsive. So I think this type of FA due to B. Here also this type FA due to C, check. Just I want to draw simply here FA due to B and FA due to C, check. Correct? Tell me FA due to B is here. This will be K. Now you can answer here minus for here. Just simply I told this thing. Put only mod value of charge and evaluate the force. Because already you know due to this minus attractive force moment, I have used that minus in case of attractive. Both have same sign, so repulsive, opposite attractive. So due to that attractive, this type of sign, right? That's all. Okay. So Q by, suppose A side length it has given A square. Here also Q by A square. Am I correct? What is this? 60 degree. Am I correct? 60 degree. Very good. So let us assume this is F. This is also F. Now simple question. Suppose this angle is 60 degree. This F. This is F. So what is resultant? Now you can solve. How? Resultant vector equals to mod equals to under root F square plus 2F1 F2 cos 60 degree. So 2F square plus 2F square cos 60 1 by 2. This is also 3F square. It means F root 3. So here also you will get F root 3, right? Now I am asking another question of you. How can you solve this question? See. Now we have one square. This is square. A side length. Here minus Q percent. Here plus Q percent. Here plus Q percent. Here plus Q percent. Right, correct? What is question? Net F on Suppose this point A, this point B, this point C, this point D. At C. C. Now check. At C, what is present? Minus Q present. Minus Q. At C, minus Q present. Here. Understood? So here force will exist, yes, due to this force, this force, this force. Understood? So here, due to this B, here force will exist, right? And here repulsive or attractive? Repulsive. I think this type of force is called F on CD to B. Very good. And due to D, check. Due to D, repulsive or attractive? Repulsive. FC on D. Here tell me, in this right angle triangle, this will be A root 2. Here force will exist, yes, exist. Repulsive or attractive? Repulsive. FC due to. Now simply we have FCD, we have FCD, and we have FCA. So what is angle? 90 degree. I already know this thing 45 because this is diagonal, right? Diagonal, this will be 45, so this is also 45. So this is another 45, and also 45, right? Okay, so tell me what is FCD? QC. Check QC is Q minus Q. But simply I told we have to take only mod way. So Q. Here Q, and here also D. Q. Q square by A square. Here also tell me Q square by, what is AC value? A root 2. Check. This will be A root 2 square. This will be Q square by 2A square. Here tell me FCB. FCB is FCB, tell me Q square by A square, right? Now if you will observe here, this will be suppose A, because every step I want to write a short term. Every step we have to write KQ square by A square here, KQ square. Just add it, let me write. F. This will be F by 2. Simply see, this is F, this is F, and this is F by 2. See. Now you have 3 vectors. First, I want to calculate vector resultant of this 2 given. Right? 1, 2, 3. Right? See that. So resultant of 1 and 3, it will be on the root f1 square plus f2 square plus 2f1 f2 cos, what is an angle? Angle is 90 degree. So this will be 2f square plus 2f square cos 90 degree. 2f square plus this will be f root 2, right? This will be f root 2. So what is f root 2? A resultant of this 1 and 2, and it will lie along this because both are equal. So what is the resultant? Angle will be 45. So already the resultant of this will lie along this direction, that is called f root 2. Now here we have 2 vectors. First is check f1 by 2, and second is f root 2. What is the angle between both? 0 degree, 0. So here resultant will be under root f by 2 whole square plus f root 2 whole square plus 2 f by 2 into f root 2 cos 0. If you solve, then you get answer. See, write one symmetrical charge distribution. Write one note. In case of symmetrical charge distribution, net force on that symmetrical charge will be 0. See here, A, 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 A. Assume here plus Q charge here also, plus Q charge here also, plus Q charge here also, plus Q charge. Very good. See here. I am asking one question here. Suppose plus Q capital charge present at point O. I told okay, calculate F net at O. How can we solve? Tell me. How can we solve this question? Tell me. Now check. Here force will exist due to discharge, 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 discharge. Understood? Here force will exist due to discharge, 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 discharge. Right? So one thing, tell me, this will be actually a by a root 2, a root 2. Complete this diagonal a root 2. So if this is a root 2, so this will be a root 2 by 2. This will be a by root 2. It means that this will be a by root 2 value. 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 Correct? At these charges, this charge present but at separation a by root 2. This charge present at separation a by root 2. This charge present at separation a by root 2. Tell me simplicity. Suppose 1, 2, 3, 4 and this fifth. At fifth, tell me here 2, 5. Forceful, repulsive or attractive? Repulsive. I think this direction. A for 1 due to 2. I think this direction. Check. A for 1 due to 2. And this is called A for 1 due to 3. Here A for 5, 5. This is A5 due to 1. This is A5 due to 4. Now check here. This cancel out each other. This will be also cancel out each other. Or is force net 0. It means this charge is present at equal distance with respect to all remaining charges. See, here also check. This Q, this charge present at a by root 2, a by root 2, a by root 2, a by root 2. This is symmetric charge, symmetrical position. Here net force 0. And in case of triangle also you can solve. In case of triangle, at centroid here plus Q charge present at centroid. So if net at O. Here also you can solve. You can assume same thing. In case of centroid, this value is a by root 3. Here also this will be a by root 3. Here also a by root 3. A by root 3, a by root 3. So this distance is equal, check, 0. Simply. Now write another question. Third charge in equilibrium. Right? What is given actually? Case 1. Where should we keep a third charge on the line joining two charges such that third charge is in equilibrium. See here. What is question? Question is, we have two charges. Suppose here plus Q here plus 4q. I have taken different, so I have taken different charges here, q and here 4q. Plus, okay, this line joining. My question is, we have this third charge, plus q this third charge. Now I want to put this third charge, I want to locate the position of this third charge such that at third charge net force will be 0, because what is the availability of net force? 0. So we have three possibilities. Either we can put this third charge here, right? Otherwise here also, anywhere. This here also, right? So one by one I want to check. This is first, second, third. In case first here, what will happen? See here. So tell one thing, all of you. Suppose here you want to fix q charge. Let us assume this distance is x and already it has given r. Assume this thing. At q, I want net force 0 here at q. Net force, third charge, this is called third charge. Right, this is called first charge and this is called second charge, right? See, third charge. Tell me here, due to this and due to this, force will exert here. Like this, due to this and due to this, force will exert here. So due to this, here force will be attractive or repulsive. I think this type is called force due to force on third due to first. Check. And due to this also, repulsive or attractive? Repulsive, because both are same side. Here also this type. Here 3 due to 2. I think both forces will lie along the same direction. It is not possible that here force will be 0. Force will be 0, suppose here this type, F1, F2, opposite. Then here we can tell, okay, force will be 0. So both will lie along the same direction. Suppose 2 Newton, suppose 3 Newton, 3, 5. Okay, minus 2, minus 2, minus 3, minus 3, minus 2, minus 5. Here force will not be equal, means it is not a position of equilibrium. Next we have a second possibility here, and here also same thing. If you will calculate, do this and do this also, both along same direction. Here also force will be not 0. Now my next final here, finally. Okay, but okay, we have to calculate what is the distance. Okay, see. Let us assume this distance is x. Here is plus q charge present. This distance L is given, so this distance will be L minus x. Am I correct? Distance will be L minus x. Next thing. Add q, add third charge particle, add plus q or third charge particle. See. Understood? See here. Here force will register, yes, due to this and due to this force also. Due to this will be go right side. F on third due to first, and due to this will go left side. Correct? This value K, Q1, Q2. Just I will simplify Q 4q by what is distance? L minus x whole square. Here tell me K Q by x square. Correct? So see here. So if at equilibrium both forces equal, F32 equals to F31. So KQ by x square equals to KQ 4q by L minus x whole square. Am I correct? Check. QQ cancel out, QQ cancel out, KQ cancel out. Simply we can write L minus x upon x whole square equals to, this will be 4. Check. So L minus x upon x equals to plus minus 2 L minus x upon x equals to plus 2 or L minus x upon x equals to minus 2. This will be L minus x equals to 2x, L equals to 3x here, L minus x equals to minus 2x, L equals to x minus x, x equals to L by 3 and here x equals to minus a. This will be considered, no? This will be neglected. Why? Because x equals to minus l means see, this is plus x, so minus x this direction. It is not possible that in case of same sign of charges, equilibrium force will reach the right side. I told at that time here force will be not this, right? So here what is x? L by 3. This will be L by 3. Yes. So this will be L minus L by 3. This will be 2 inverse. So what are telling? So write one trick here. Write one trick. If you have plus plus charge or minus minus charge, so distance from smaller charge x, and x will be equals to under root q1 upon under root q1 plus under root q2, it's representing both L. What is q1? Here q1 is smaller charge L is this between already given Q1 Q2 charges, right? L is distance between Q1 and Q2. What is x? Distance between Q1 and this smaller charge and like Q1 and given third charge root Q1. Suppose this is Q1 charge, this is Q2 charge, and here your third charge plus Q. Assume this distance x, this distance L minus x. Now we have to take x. This will be Q1 mod upon this under root Q1 plus under root Q2 into L. That's it. Solve this question. And I want to tell one question here. We have a plus Q charge and minus 9Q charge, correct? Plus Q charge and minus 9Q charge. Distance L. Now here should we have to keep third charge particle such that net force on third charge particle will be 0 or equilibrium. Correct. In this case, we can do one thing. Plus Q charge here, minus 9Q charge here. Here also 3 possibilities. But see, I want to tell you one trick here. What is trick? In case of opposite charges means plus q and minus value opposite charges. Equilibrium position or equilibrium location will exist near the smallest charge between that given charges and left side of smallest charge. You already observed in case of plus q and plus 4q. I want to tell one trick here. If in case of both charges same sign of charges, same sign, plus q plus 4q, same sign. Here force will exist, equilibrium position will exist near the plus q, near the smallest charge, but right side means between that given charges. Between means here x, I think this will be L by 4 was no? And this will be your 3L by 4. So here you can put that third charge such that force will 0. So I want to once again repeat. Between both same types of charge, both same like charges, like charges. In case of like charges, we can put a third charge between the like charges and like on the end near the smallest charge such that net force here will be 0. Here also, in case of different charges, we can put the third charges near the smallest charge and left side of this charge. We can solve. We can put here plus q. This will be x. Now tell me here. If you will solve, then you will get. But I want to write simply. X will be under root q1 upon under root q1 minus under root q2 into L. Check. So, thank you so much.